And yeah, so in the last class, we went through survival analysis, and we spent a little bit of time thinking about the definitions of time to event data. Okay. And, you know, we defined 3 common terms. So what I'm going to do now is I'm going to give you an example. And then if anybody wants to just raise their hand and tell us what the target event is, what the time origin is, and what the time scale is. Okay. All right. Example. You are an obstetrician and you're conducting a study looking at the effect of zinc supplementation on whether the baby survives or not. And so the baby survival might come in the form of maybe an abortion or a miscarriage, a spontaneous abortion or a miscarriage. It might come in the form of, you know, a fetal death. It might come in the form of a stillbirth, right? But up till the time when the child is born, you want to see whether the baby survives. So at the time when the child is born, you stop your study. Again, you start the study from when the woman starts antenatal care. Okay? And then you follow them until the time when the child is born. All right? And they're coming to clinic every month, or, you know, you're measuring the gestational age in weeks, that kind of thing. So somebody wants to tell us what the target event is. Anyone? Yeah, go ahead.
I think that the target event is the outcome ranging from the abortion to either a live birth or a fetal death.
Right. So the pregnancy loss is the target event. Very good. Yeah. Somebody else wants to tell us the time origin. The time origin. Anyone else?
The start of the antenatal care, when they enrolled for antenatal.
Yeah, so when they started antenatal care clinic, that's just the time origin. Very good. Anybody else wants to tell us time scale? Time scale, anyone else? You could use weeks, okay. You could use months, and varies. Okay, let's take another example, and then we'll have a new set of people who haven't, you know, who haven't participated to just try. You are interested in, right? You are interested in assessing whether. Okay, let me think about this for a moment. You're interested in assessing whether introducing a new teacher and introducing an extra teacher. So say, let's say in the schools in your community, right? There's many schools, and then there's complaints that the classrooms are too packed. And I want to use a setting outside of healthcare so that you can see that these methods also translate. People are saying that people are saying that the classes are packed, and you decide to hire an extra teacher for each school. Okay. And so when you hire the extra teacher for each school, so you hire an extra teacher for some schools, some other schools you don't hire an extra teacher. But then all the schools in your community are the schools that you include into your study. Okay. And you follow up the kids from all those schools to see how many kids graduate on time. Okay. So whether they go to, let's say this is secondary school setting and they have to write an exam at the end of secondary school. So you're trying to see how many schools graduate on time, how many kids graduate on time, or how many kids drop out of school. Okay. So Can someone tell us what the time origin of this study is? So let's say you start the study in the year 2015, right? And then you follow up the kids up till the time when they graduate, and say you conduct the study for 5 years. So you follow the study.
Give it a try?
Okay, give it a try.
Yes. The time origin is when a child drops out of school or when he or she graduated.
Is that the time origin? So think about what the time origin is, which is supposed to be the beginning, right? You're following up from when you start the study. So somebody else wants to give it a shot.
So
the time origin is the time you started the study itself. The time you started the time you started with this you started the study itself.
The time you started the study is the time origin, yes.
Yes.
So because in many times when we when you start a study like that, the way you design the study affects how you define each of these terms. So that's the time origin. But the other thing is a target event. Molly, do you want to answer this one? What is a target event?
Okay, the target event is the graduation of the students or the students that dropped out.
Yes, the time when the graduation of the students, yes, that's the target event. Very good. And so what's the time scale? Anyone?
I think the time scale is from your example, 5 years period.
Yeah. So is it years or months or days? Anyone that you choose is the time scale. Okay. And remember, we said that sometimes the time scale is not actually real time. It might be mileage, right? In some situations where it makes more sense to not use time, but to use some other scale. All right. So we talked about this extensively, but the other thing that we did talk about was, immortal present time. So, and can somebody explain to us what we said immortal present time was? Anyone wants to try? So if you remember, we said that sometimes you start the clock of the study from a period when a person could not have had the outcome, right? Like it's unreasonable. So in the example that we just saw, right, a person can drop out of school anytime. So you can start the study in 2015 and they're in GSS1 and something happens to their parents, God forbid, and they stop coming to school, they drop out, or they might drop out in SS3 or, in the 6th class, that kind of thing. But if you think about in the context of like teenage pregnancy, right, there are kids who start school, who start secondary school before they enter puberty. So if you are going to look at it, do a study where your outcome of interest is teenage pregnancy, but you're looking among secondary school girls because it's convenient for you, you would inadvertently include some kids who could not become pregnant because they were not even at puberty yet. You see what I mean? So that is immortal present time or immune present time. Another example is, where, for instance, you're studying HIV patients, okay? Now, for a person to develop a AIDS-related death, they have to first have AIDS. But most HIV patients, when they start, right, they are unlikely to have AIDS-related death at the beginning, because at the beginning of their infection, the stage of their disease is such that AIDS-related death is unlikely to happen. But it's more convenient for you to include everybody who has HIV infection, maybe everybody in your center who has HIV infection. So even though you're including them at that time, it's unlikely that they will have AIDS-related death in the initial years of their disease. That period when they are unlikely to have AIDS-related death is a mortal person time. Okay, you're including people into a study at a time when they're unlikely to have the outcome, but you're doing it because it's convenient. And sometimes, you know, one thing to do is to try to avoid including them at that time. You know, maybe include only people who have AIDS at the time of starting the study and then follow them up. That's one way. Or adjust. You can use statistical approaches to try to adjust for the severity of the disease. So you will conduct the study as you do, but you ask people about whether they have AIDS or not. And then you would include that in your model as a confounder. Okay. All right. So that's a mortal person time. The other thing we talked about was censoring. Does anybody want to give it a shot? Do you remember what we said censoring was?
Censoring is when we don't know what happens to the person. Maybe just lost contact or something. We don't even know the person.
Yeah, excellent. So censoring is when we don't know the outcome that the person experienced. Okay. It might be because we lost contact with them, or it might be because the study ended before they experienced the outcome. Again, we said it might be because we lost contact with them, or because the study ended before they experienced the outcome. What did we call it when the study ends before they experience the outcome? Anyone? Yes, you've done a study for 5 years and you're following people up to see whether they die. Administrative censoring, very good. Okay, administrative censoring. All right. Now, we also talked about two different other types of censoring. We said left censoring and right censoring. Does anybody remember and wants to tell us? If you remember, I said one is here and one is here.
So I think for the left censoring, the event had occurred before the patient or the respondent had been recruited.
Excellent. Excellent. That's left censoring. Okay. And what is right censoring?
While for the right, the study has been concluded, then the patient now had the event.
Not necessarily. So anytime after you start the study, that is right censoring. So right censoring is the censoring that we're actually interested in. Okay. So it might be that the person had the event during the study, or they had the event after the study had ended. So that is right censoring. Okay. All right. Very good. So the other thing that we then talked about was the Kaplan-Meier plot. Does somebody want to try to explain this plot to us? Anyone? You're looking at the paper and you see a plot that looks like this, and they said, oh, this was a plot that we got from a study where they followed up, you know, resident doctors from the time when the study started for 10 years to see whether they stopped working in that specialty they were training in. How would you interpret this plot? Does it just look like zigzag? Or...
Hello, sir. Can I give it a try? Good evening,
yes,
sir.
please go ahead.
Okay, sir. The Kaplan-Meier plots, each of these stick here, that's the okay, let me start with the step.
Okay.
Each of the step here means that one of the participants in the study have had the outcome of
okay,
interest.
One or more, yes.
One or more of the participants here. Then each of these sticks here represents censoring.
Censoring.
Yes.
Excellent.
Yes.
That's excellent. So that's basically what it is.
There's also something else here. Like we can see a place where you're having a step down and then a horizontal tick.
This one?
Right. Yes, yeah. So this means that at this time, one or more persons are having the outcome of interest. We're also having one person or so who is also being censored.
Censored, very good. Yes, that's it. Yeah, that's very well explained. And basically what this says is that you start from, when you start the population, you have everybody in your population. None of them have experienced the event. None of them is censored. But as you go over time, some people either experience the event or are censored. And by the end of the study, right, it's either everybody has experienced the event or censored, you know, or you don't know whether they have experienced the event. And so you end the study and administratively censor the rest of the people. So in this particular population, only about 15% of the population ever experienced the event or were censored. That means that 85% of the population, right, never experienced the event. At the end of the study, 85% of the population, you knew that they had not experienced the event, and you know where they were, you could reach them, that kind of thing. Okay, so that's a Kaplan-Meier plot. And we said that you can have a 95% confidence interval that tells you, you know, how, you know, like that gives you an idea of if you had repeated this plot many times, repeated this experiment many times in your population, what you would have gotten. But the confidence interval is most valuable for when you're comparing two plots. Okay, so if you look at these two plots, right, you have males in red and females in blue. Which population would you say is experiencing the outcome most often? Anyone?
Okay, so can I try again?
Yes, go ahead.
Okay, I think the males are experiencing the event more.
Why is that?
Okay, we're having multiple of the step downs.
Having more step downs, yes.
More step downs, yes. So,
yep. And so you can see that it goes down very quickly.
Down, yes, sir.
Yep. So that's basically what it is. Males are experiencing the event more, but we said that the confidence interval, you know, can help you to see whether this is significantly different, right? So in this case, we can see that the confidence intervals overlap. So that means that it's not really much different from each other, right? But the other thing we said is that there is a log rank test. And the log rank test can be used so sometimes you see this plot, you see two or more groups, and then you see a p-value. And somebody will say p equals, you know, 0.09. Okay? This is not supposed to be Q. So you see a p-value, you see a plot like this, and they write p equals 0.09, and that p-value is from the log rank test. Okay. Can someone tell us how would you interpret this p-value if you just saw the p-value like that in this plot? Anyone? We talked about this in passing the other day. It was very quick. So this is an opportunity for us to really talk about it briefly. Anyone? How would you interpret a p-value of 0.09? Would we say that the survival in the groups are significantly different or not significantly different?
It's not significantly different.
Can I try, sir? Okay, sorry.
We would say that it's not significantly different, yes. So basically that's what the log rank test does. It just compares the survival across the entire length of the curve, and it gives us a p-value, and based on the p-value we can say whether it's significantly different or not. All right,